Today's topic we'll be talking about lowest common multiple, that is LCM. Okay, let's find the LCM of these two numbers 144 and 66. Okay, first of all, we'll find the prime factorization of the two numbers. Let's start with 144. Draw a line down, then draw a line below the number you want to divide. You divide by prime numbers. We have the first six prime numbers are 2, 3, 5, 7, 11, and 13. There are other prime numbers, but these are the first six prime numbers. So what we normally do is this: you take the least, you try to divide whichever given number by the least. If it is not divisible by it, that is, if it's not cannot divide without remaining any number, you move on to the next prime number on the list until you are able to get a prime number that can divide that whole number without a remainder. Okay, so 2 is the first prime number which can divide this number without a remainder. Okay, 2 in 14 you get 7. 2 in 4 we have 2. Okay, 2 can still go, so you write 2 there, put a line below 72. 2 in 7 you have 3. Remember 1 you take to 2, which makes it 12. So 2 in 12, that's 6. Okay, 2 can still divide. Okay, 2 in 3 you have 1. Remember 1 you take to the 6, which now 16. So 2 in 16 you get 8. 2 can still divide. 2 in 18 you get 9. Okay, as you can see, this time around, if we divide 2 by 9, we will have a remainder. So you move to the next prime number, which is 3. Possibly 3 can divide 9 without a remainder, which is 3. Okay, and 3 can divide 3 by itself, which gives us 1. Okay, so the prime factorization for 144 is, we have 1, 2, 3, 4. That's 4 2's. 2 times 2 times 2 times 2. Okay, then we have 3 2's times, no, 2 3's. That's times 3 times 3. So these are the factors that gives us 44, right? Okay, so now let's do the prime factorization for 66 on this side. 66, remember you draw a line at the bottom. Let's divide by 2. 2 can go. 2 in 6, 3. 2 in 6, 3. Okay, 2 can no longer divide, but 3 can divide 33. So 3 in 3, 1. 3 in 3, 1. 3 can no longer divide without remainder. There's going to be a remainder 2. Okay, 5 cannot do that. 7 cannot. There's going to be a remainder. So 11 will divide itself, which is 1. Okay, so remember this is 2. So the prime factorization for 66 is 2 times, let me put it below the 3 here, times 3, okay, times, let me bring 11 here, 11, okay. So looking at this, how do you find the LCM after we've gotten the prime factorization all out? Okay, the LCM for this number is, you look out for the factors, the factors that appear most in any of the given number. Okay, we have 2. The prime number 2 is a factor that is appearing how many times here? 4 times. Okay, so in the factor of 66 we have just 2 appearing, just 1. So we go for the highest, okay, which is 2 times 2 times 2. Okay, so you write that out, 2 times 2 times 2 times 2, 4 times. Okay, so you look for the highest of the factors that produces the given number. Okay, so then you go to the next factor. The next factor is 3. Okay, in 144 we have 3 appearing, multiples of 3 appearing 2 times, while in 66 we have it just 1. Okay, so we go for the highest, the multiples of 3 appearing 2 times. Okay, so we'll bring that down, times 3 times 3. Okay, then we'll go look around for the next factor, the next available factor. Okay, the next available factor is 11, and there is no order, it is not appearing in 144, quite alright, but it is the only factor that we have in the prime factorization of these two numbers, so we'll bring it down. Okay, times 11. So we multiply all the numbers together to get the LCM. It is best to use calculator, because let's use calculator. Okay, 2 times 2, 4, times 2, 8, 8 times 2, that's 16. So 16 times 3, that's 48. 48 times 3, that's 144. 144 times 11 gives us 1584. Okay, so the LCM is 1584. Okay, but remember, let's take a recap of HCF. Having found the prime factorization, which is this and this, you can also or equally find out the HCF, that's the highest common factor. The highest common, in the case of the highest common factor, you look for a factor that appear in the 2 given number. Okay, which is 2 is appearing as a factor of 144. Okay, and it's also appearing as a factor of 66. Okay, so you bring that 2 down. Okay, then you look for another factor. 3 is another factor that is appearing in 1 as a factor, the product of factor of 144, and also a product of factor of 66. Okay, you bring that down, times 3. What about 11? 11 is only appearing as a factor in 66, but is not appearing as a factor in 144, so it cannot be counted as a highest common factor. So 2 times 3, which is 6. So if you look at the similarity between LCM and HCF, you will discover that LCM, by its definition, doesn't really explain how you get to find LCM of any given number. Okay, because LCM, you look for the highest multiples that appear most in any of the given numbers. Okay, like for instance here we have a multiples of 2 4 times. Okay, so you bring it down. Then in here we have a multiple of 3, which is appearing most in 144. So you bring it down, times 3 times 3. And the last factor, which is 11, because it is not appearing in any order of, that's the only factor that we have, so we bring it down. Then you do a multiplication of all the numbers, and that's how you arrive on LCM. Okay, thank you for watching, and watch out for more lessons on how to find LCM of any given numbers. Thank you for watching. God bless.